Hi guys, very good evening. Welcome to Gradeup, India's largest e-learning platform. Okay, so today in the series of this NIELIT score booster, we are going to deal the computer organization and architecture. So the part 1 of the computer organization architecture, 3 parts of digital logic we have already finished. You can also go through the links what we have given earlier for all the 3 sessions, part 1, part 2 and part 3 of the digital logic. And now we are starting with part 1 of this CO. So total in the series is the part 4. Computer instructions we'll see. So we are having 3 parts in the COA also, today, tomorrow and also on Monday. Okay. So here in COA, computer instructions, instruction pipelining and cache memory organization, these parts will be discussed. And I hope you will get advantage of this. Okay. You can go through this site and Gradeup site, and you can download the Gradeup app from the Gradeup app, that's Play Store, and also you can subscribe to the YouTube channel. So we are having more than 3 lakh subscriptions for the YouTube Gate channel. So you can go through that and you can get an advantage of all the free videos related to multiple sessions. Like we are having IIT Bombay series session and multiple selective questions, and also these NIELIT programs and special subject wise things also we are giving. So try to get an advantage of this and subscribe the channel, and also like the channel if you are really liking it, and you can also share with your friends. Okay. So now before starting of the session, so let me introduce myself. Myself Murali Krishna. I am having 20 years of teaching experience both in the GATE and also in different engineering colleges, and I am topper in one of the NPTEL course that is conducted by IIT Kharagpur in the year 2019. I should top in that exam with 96% marks, and I am certified as international engineering educator and also qualified in the GATE exam, trained more than 50,000 students across the country in different core areas of computer science and engineering. Those are theory of computation, TOC, operating systems, OS, computer organization and architecture, COA, computer networks, CN, and digital logic design, that is a DLD. So these are my areas. This is about my brief profile. So I hope you will enjoy the session. So this session is important for answering the questions of computer organization and architecture. So especially related to the questions of computer instructions. Okay. So before starting of the session, quickly I will recap of whatever the courses we are offering here. So in the Gradeup, we are offering 3 courses for computer science. If you are appearing for GATE CS, so that exam qualification is sufficient for ISRO exam to prepare, and also BARC exam, and also NIELIT and DRDO. So these 4 like ISRO, BARC, NIELIT and DRDO. So there is one important announcement related to the NIELIT exam. Okay, so there is an update on this. So exam is being postponed to 22nd November. So exam is on 22nd November. Okay, you just observe that change. So there is an important announcement regarding the NIELIT exam. The NIELIT exam is on 22nd November. Okay. So because all of you are appearing for the NIELIT exam, you might have been in preparation. Just an important update I am telling you. You can go through the link in the Gradeup app. It is updated. You can go through that. So that is on 22nd November once again. Okay. So now this for computer science, the Gradeup is offering 3 courses. One is a Gear Up, other is the Rank Up, and third one is a Vision. So in a Gear Up, it is a short-term course. It is for 2021 aspirants, and Rank Up is also for 2021 aspirants, and Vision is for 2022 GATE. So it is a long-term program. These 2 are short-term programs. So in Gear Up, we are offering 300 plus live classes, 3000 plus practice test, and also 40 plus mock test. These are practice questions, 3000 plus, and 70 plus chapter-wise study notes. So this Gear Up course is useful for, it is ideal for the students who wanted to revise the entire GATE syllabus and also wanted to learn the fundamentals. And this Rank Up course is ideal for the repeaters who wanted to write the GATE exam one more time to improve the score. And more emphasis on the problem solving. It's a score improvement program, and this is also containing 3000 plus hours of live classes, 300 plus hours of live classes, and 3000 plus practice questions, 40 plus mock test, and 75 plus chapter wise study notes. So this is ideal for problem solving. More emphasis on the problem solving. It is an ideal for repeaters. And Vision is ideal for second and third year students, because all the core subjects of computer science or any other branch will begin from the second year. So when you start the preparation for the second year, by the time when you come to third year or for appearing GATE or for final year, at least 4 subjects you can finish. Okay, so now 550 hours of live classes, for more than 550, around 600 hours of live classes we are offering for Vision 2022, and 5000 plus practice questions, 100 plus mock test, and 100 plus chapter wise study notes we are offering. Okay, so try to get a full advantage of this Vision course also. In Vision, we are having more number of questions, and in every this course we are offering very good qualitative questions also. Okay. Sonal Priya, good evening. Pooja Gupta, good evening. Pratik Gar, good evening. Ajit Yadav, good evening. Poonam, good evening. Okay. Yes, NIELIT admit card, actually there is a change. Please observe that change. So exam is on 22nd of November. So very good evening, Sanket. Yes, SJ, good evening. Okay. So for all these things, if you have any doubts, you can reach us at 96500 Okay. And Himanshu, good evening. Priyanka, good evening. Jamal Ahmad, good evening. So happy to see all of you once again. Please stay till the end of the session. Don't leave the session in between. So because if you go through this session, so you will understand what type of questions will come in computer instructions. So total we have divided the COA into 3 parts. Computer instructions based on the importance of the questions we are getting, and the instruction pipelining we are discussing tomorrow. And on Monday we will discuss the memory, that is a cache memory organization. Okay. So this is about these courses we are offering. And coming to the faculty who are teaching for these courses, Gear Up, Rank Up, and the Vision. So right now we are having 4 faculty members, expert faculty members, and myself, Murali Krishna, 20 plus years of experience. Satyanarayan sir is having 13 plus years of experience, and Ankit Doyle sir is having 8 plus years of teaching experience, and Navneet Gupta sir is having 7 plus years of teaching experience. Okay. So all these 4 faculty members are expert in their respective subjects. Try to interact with this and get an advantage of scoring better. Okay. So now let us see what are the problems, the type of problems we are getting in the NIELIT exam on as far as the computer instructions are concerned. Okay. So if this type of problems are, if you are prepared, then it will be useful. Definitely you will get succeed. Okay. And Himanshu, good evening. Priyanka, good evening. Pratik Soni, good evening. Okay. So in the comment box also, after the session is finished, apart from this chat box, after the session is finished, you can continue commenting, and most of you are commenting on the digital logic sessions. That is in the previous day, yesterday, day before yesterday, day before yesterday, we have got the sessions, and still the discussion is going on those sessions also. In a similar lines, you can also discuss the questions on the comment box till your examination, till the November 22nd. Okay. So now coming to the first question, consider the following instructions. So meanwhile, you can just subscribe to the channel if you have not yet been subscribed. You can also share the information of this YouTube link with your friends, and also the information related to the link that is forwarded below. That is, you can follow me in the Gradeup app, so that you will get all the notifications related to my free classes also. And even YouTube channel also, if you subscribe, you will get a notifications whenever the classes are available. Right? So Uma Reddy, good evening. Aditya Desai, good evening. Piyush Srivastava, good evening. Okay. So instruction I1 is add R1 comma R2. So where R1 is 1 register and R2 we are taking, R2 within the parenthesis indicates this is a register indirect mode, and we are adding the content of R1 and also content of memory at address indicated by R2. So that's the meaning of that. So one operand is a memory operand, one operand is a register operand. So multiplication R1 comma R3, same thing. Okay. So the updated value of R1 should be taken for the second instruction, because there are contiguous instructions. So what is the content of R1 initially? Content of R1 is 10 and the content of R2 is 100. So the content of R2 is 100. Content of R3 is 200. Okay. Content of memory at address 100 is 15. So if you go to memory at address 100, so the value of memory content at address 100 is 15. Okay. And the content of memory at address 200 is 20. So if you go to memory at address 200, so there is a value 20. Okay. Now, what is the value of register R1 after the execution of instruction I2? So first instruction, What is this? R1 plus M of R2. So what is R1 content? 10. And the content of memory at address indicated by R2. So what is R2? 100. That means through the register R2, I have to go to memory at address 100. That means 15. So 10 plus 15, so you will get 25. So 25 is a value that is to be stored in R1. So the recent value of R1 is 25. The updated value of R1 should be taken in I2. R1 comma R3. So what is R3 value? 200. You have to go to memory at address 200 means 20. So 20 is one operand. So that is added to R1. So R1 is 25. So not addition, it is a multiplication. So 25 star 20. So it is a 500. Okay. So 500 is a value. So finally we get into R1. So after the instruction I2 is being executed. So option B is a right option exactly. Yes, 500. Pratik Soni, you are right. So 500 is a value that will be going into the register R1 finally after the instruction I2 is being executed. So two instructions are contiguous. So updated value of R1 by the instruction I1 has to be taken as an operand for the I2. Understand? So 500. Priyanka, you are right. 500. Okay. Now coming to the next. So please stay till the end of the class so that you will get a lot of benefits of attending this class because all varieties of problems, whatever are possible, I am explaining. Later on, these models we can prepare and also some other models of related to these chapters. So and you can also continue discussion in the comment box. So I will reply all your doubts. Okay. So a computer has 32-bit instructions and 12-bit addresses. If there are 250 two-address instructions, then how many one-address instructions can be formulated for this computer? So what is the instruction size? 32 bits. This is the instruction size. So this computer is having both two-address instructions and also one-address instructions. For example, if you take a two-address instruction, okay, so this 32-bit address will be divided into opcode followed by address 1 and address 2. This is divided into opcode followed by address 1 and address 2. So what is the address size? 12 bits. So address 1 is a 12 bits. Address 2 is also 12 bits. So 12 plus 12, 24 out of 32 bits. Then how many bits will be remaining? 8 bits will be remaining. In a computer, we have one address instructions and two address instructions, whatever it is. But no two instructions should have the same code. Different instructions must have the different code. Okay. So if I use only two address instructions using 8-bit opcode, 2 power 8 operations I can perform. That means 256 instructions are possible actually. If you have used all 256 instructions for a two address, then one address will be 0 because there is no code left over and you can't use one address. But he has used only 252 address instructions. That means 250 combinations are used out of 256 combinations. So 256 minus 250, there are 6 combinations left over. But as far as the one address instruction format is concerned, for a 32-bit instruction, okay, for a 32-bit instruction, we can use the first address part also as a opcode. Already existing opcode bits followed by address 1 can be used as a opcode, which is of 12 bits. So this is 8 bits, this is the 12 bits. Total now we are having the opcode value as 20 bits. But out of this, whatever the combinations that are used for the two address instruction, that cannot be used. Only 6 combinations are left over. For those combinations, these 12 bits can be arranged in 2 power 12 ways. So 6 into 2 power 12 combinations of opcodes we can further provide for the one address. So 2 power 12 is nothing but 4096. So it is a 6 into 4096. Option C is the right option. I hope you have understood. So option C is the right option for the second question. Okay. So if the number of one address, two addresses are there, no two instructions, including one address, two address, should have the same code. No two instructions should have the same code. Okay. Now coming to next, third question. Yes. So I don't understand. Could you please tell me, is there any class? What is that, Srinivas? I didn't understand your question, Srinivas. Okay. Okay, I will repeat the second question once again. Okay, let us suppose I am having opcode bit 4 bits. Let us suppose using 4 bits, I can have the combinations like 0 0 0 0 0 0 0 1 to 1 1 1 1. So 16 combinations I can have. Out of 16 combinations, if you use 12 combinations, how many combinations will be left over? 4 combinations will be left over. For each of the combination, the address part can be arranged according to the bits available. So here the address part available is 12 bits, right? So the leftover 4 combinations here, what I am using into 2 power 12. So this is 4096. 2 power 12 means. Okay. So here it is a 6 combinations left over. This is another example I am taking for understanding. This is another example. Okay, 6 combinations are left over. That is a 6 into 2 power 12 we have taken. Okay. Now coming to this question. A 32-bit processor has a 64 general purpose registers. The number of general purpose registers are 64 and 256 kilowatts of main memory. This is the main memory size, 250 kilowatts. Okay. And when there are 2 power 64 general purpose registers, one register can be identified using 6 bits because log 64 bits are required in order to identify one register. So like we require a 6 bits to identify a register. Using 6 bits, we can have the addresses of register from 6 zeros to 6 ones. Total 64 values. 6 zeros to 6 ones. Now memory is 256K. 256K is nothing but 256 is 2 power 8, 1K is 2 power 10. So there are 2 power 18 words in the memory. If you wanted to address one word of memory, we require 18 bits. If you wanted to address one register out of 64 register, you require a 6-bit address. The register address requires 6 bits, memory address requires 18 bits because there are 2 power 18 words. Okay, the instruction has 4 parts: an indirect bit, an operation code, a register code, and an address part. Then how many number of bits can be used for the operation code part of the instruction? It's very simple. So what are the 4 parts? He is mentioned that 32-bit processor. In a 32-bit processor, the word size is 32 bits. A processor is of n-bit processor if it is able to process n bits of data at a time. That means the word size would be taken as 32 bits, n bits. So here n value is 32. Now there are 4 parts. Indirect bit, that is a 1 bit, followed by opcode bits. We do not know how many operations it will perform. And we are having a register code part to identify one register out of 64 registers, and we are having an address part. This address part is to identify one address word of memory. Okay, so there are 2 power 18 words, so one word can be identified using 18 bits. 18 bits. Okay, now there are 64 registers. One register can be identified using 6 bits because the registers we are referring here are from the available set of 64 registers only. Now what is it? This is indirect bit 1 bit. 18 plus 6, it is a 24. 24 plus 1, 25. Then 32 minus 25. Because the total size of instruction is 32 minus of this is 18 plus 6 plus 1. Address part, register address part, and indirect part. So total it is 25. So 32 minus 25. I hope you understood this question. So 7 bits will be left over. So the opcode value contains 7 bits. So like this we can solve the computer instruction problems. So now how many bits are left over for opcode according to this requirement? 7 bits. So option B is the right option. Exactly. Most of you have given like Anku Kashyap, Shweta Pandey, Vrishab Pandey, Pratik Soni, all of you are right. Exactly. Okay. Now coming to the next question. I hope you have understood this, right? Now the reverse Polish notation of the following expression. So you may have a doubt in computer organization why we are using this prefix and postfix notation, because in a stack organized computer we use this in a zero address instructions. In a stack organized computers we use this type of notation. RPN notation is nothing but reverse Polish notation. So reverse Polish notation is used in stack organized computer. Reverse polish notation is also called as the postfix notation. For a pre-order prefix notation, we use the Q. For a postfix notation, we use the stack. This is also called as the postfix notation. Postfix notation. So listen carefully, I will tell you how to convert this. Postfix notation is nothing but left, you have to evaluate right side, then root. Left, right and root. Root is at last. Okay. So this is expression in fact. So what is expression? This is expression. So the main operator is a slash here because A plus B minus C. B minus C is also in bracket. A plus B minus C is in bracket. So you have to evaluate the left side, then slash D star E. You have to evaluate this. So that means the main operator we can consider as a division. So this is the left side, this is the right side. Within the left side again, plus is the main here. Okay, this is the left side of main, this is the right side of main. So left side you have to evaluate. So A, right side is B minus C. Again B minus C, B is left, C is right and minus is root. So after that we have to perform the plus. And after that right side. Right side means D, E star and again slash. So ABC minus plus DE star slash. ABC minus plus DE star slash. So option B is the right option. Exactly. But if you do it with the stack, the infix also, we can just justify the answer by using the stack. So we can push as and when these are encountered. So we can push A into stack, we can push B into stack, we can push C into stack. So when minus is encountered, we have to perform subtraction. So top of the stack is by default operand here. So A will be there, B minus C on the top. So minus means top of the stack is subtracted from the next to the top. So second operand, top of the stack is second operand. Now we got a plus. We have to add the top of the stack to the next to the stack. So that is A plus B minus C is evaluated and it is available in the top of the stack. Now D, we have to push the D. We have to push the E. Both are pushed. Next star means E must be multiplied with D. So A plus B minus C already available on the bottom and we have to perform D star E. D star E is on the top. Now slash. Slash means we have to divide A plus B minus C. A plus B minus C, we have to divide this with the D star E. Slash D star E, that's all. So this is the justification. So I hope you have understood. Option B is the right option. Is it clear? Okay. So please stay till the end because we are having further 5 more questions to go. And I think second question you are not understood. Some of you are sending second question. Second question once again I will explain. Please listen. Once again, second question I will explain. Okay. So we are having a 32-bit instructions, right? Out of 32 bits instruction, we are having a 12-bit address. We are having a 12-bit address. So 12-bit address and opcode value is also there. Opcode followed by address 1 and address 2. So each address is a 12 bits. So here we are having 12 bits. Here it is a 12 bits. 12 plus 12, 24. 32 minus 24 is 8. So using 8-bit opcode, the maximum number of operations possible is 256. Because 2 power 8. Out of 256, I have used only 250 two address instructions. That means 256 minus 250, only 6 combinations are left over. In a one address instructions, those leftover combinations can be used. In a one address instruction, the existing 8-bit opcode and also the first address part can be used as opcode because in a one address instruction there will be a single address. That means it is extended opcode. So entire thing can be used as opcode. This is 8 plus 12 plus 12. So the combinations that are used, 250 combinations for each of the 250 12-bit address might have been used. So we should not have a repetition of code. Okay. So that's why whatever are left over the 6 combinations, for that these 12 bits can be arranged in 2 power 12 ways. 6 into 2 power 12. So that is nothing but 6 into 4096. Option C is the right option. That's all. Now coming to the 5th question. A digital computer has 2 address instructions which has a register and memory addresses. a digital computer has two address instructions which has a register and memory addresses. If there are 32 registers and 1 megabyte of memory, the number of registers are 32 and we are having 1 megabyte of memory, and it is able to perform 16 operations and has 8 different addressing modes, then the size of the binary instruction code in bits is very simple. So what are the parts here we are having? We are having a computer has two address instruction which has a register and memory addresses both. Okay, there are 32 registers and 1 megabyte of memory, and it is able to perform 16 operations and 8 different addressing modes. Okay, so now you see this, we are having the mode part is there in the instruction, opcode part is there, and a register address is there, and also memory address is there. Register address part and also memory address part. So these are the parts of the instruction: register address part and the memory address part. Okay, now this is the mode, this is the opcode, this is the register code and memory address. So total we do not know what is the size, we are supposed to find out now. Okay, so mode bits we have to use 8 different addressing modes. That means one mode can be identified using log 8 bits. So log 2 power 3 base 2, that is nothing but 3 log 2 base 2, that means 3 bits. So 0 0 0 indicates one addressing mode, 0 0 1 indicates one addressing mode, 0 1 0 0 1 1 and so on 1 1 1. These are the possibilities. So that means we have to use the 3 bits for the mode. And opcode bits we are performing, operation to be performed is nothing but opcode. 16 operations we are performing means, so the number of bits required is log 16. So 4 bits are required. For the operation code we would require 4 bits. Is it clear? Okay. And for the register address, what is the register address? How many registers are there? We are having 32 registers. For 32 register, to identify one register, we require log 32 base 2. So that means we require 5 bits. So the register address would be 5. Okay. And memory address, we are having 1 megabyte of memory. So 1 megabyte of memory is nothing but 2 power 20 bytes. 2 power 20 bytes. So to identify 1 byte out of 2 power 20 bytes, we require a 20 bits address. So the memory address will be 20 bits. That's all. So sum of all these will be the instruction size. So that means 20 plus 5 plus 4 plus 3. So total 32 bits. Exactly. So we require each instruction size of 32 bits. Okay. So I hope you are enjoying the session. So meanwhile, let us have a small announcement, a very important announcement related to the NIELIT exam. So there is a change in the examination date of NIELIT. That will be conducted in the month of November 22nd. Please observe this change. Thank you. Okay. Now coming to the next question. So C is the right answer for this. Yes, most of you have sent C. Like Kashyap, Pratik, Jamal, Lakshmi. Okay. And Vrishab. Yes. Okay. Now coming to the 6th question. Consider a computer system with an instruction set of 20. What do you mean by instruction set of 20? That means we are having 20 different instructions in an instruction set. 20 different instructions. Every computer is supposed to have the instruction set. Okay. So maybe when you are writing a program, one instruction may be written multiple times. That depends upon your data processing. Okay. And the memory size of 64K into 32. That means there are 64 kilowords. Each word is of 32 bits. 64K is nothing but how much? 64K is nothing but it's the 2 power 16. So it's the 2 power 16 words. So I can say memory size is 2 power 16 into 32. So one word size is 32 bits here. This is a RAM. One word size is 32 bits. Each instruction is of one word in size. So one word in size in the sense instruction size is 32 bits. 32 bits. Instruction has 4 parts. Observe carefully. An opcode, a register code part to specify one out of 32 registers, and an address part, and an immediate operand. Okay, I am just writing here the instruction parts. So what is that first one? Opcode. Opcode indicates what operation is to be performed. And what is the next part? A register code part to specify which register you are using. So this is the register part. Okay. Then an address part. Address part is a memory address. From which memory location you wanted to get the data or operands. And followed by immediate operand. Immediate operand means the data is available within the instruction itself. This is the immediate operand. What is the total size of instruction? It is a one word instruction. What is the one word size? It is a 32 bits. We are having 32 bits as one word size. Out of 32 bits, as a computer is performing 20 different instructions, to identify one instruction out of 20 instructions, we require minimum log 20 bits. Log 20, if I use 4 bits, only 16 instructions I can show. 5th bit is mandatory. Okay, so 5 bits are sufficient to identify one operation code out of 20 operation codes. Of course, using 5 bits, total 32 are possible. Out of that, only we use 20. So, how many registers are there? 32 registers are there. To identify one register out of 32 register, log 32 bits are required. So, that is nothing but this is also 5. Because 2 power 5 is 32. So, we require 5 bits. Each register to identify, we require 5 bits address. Now, address part. So, what is address actually? There are 2 power 16 words. To identify one word, we require 16 bits. To identify one word of memory, we require 16 bits. So, this address part is a 16 bits. Okay, now immediate operand value. What is the immediate operand value? Immediate operand value remaining out of 32, 16 bits are gone for address, 10 bits are gone for opcode and register. Total 26 bits are gone. So the remaining can be used for immediate operand. So 32 minus of 16 plus 5 plus 5. So 32 minus 26. So 6 bits. So we are using 6 bits. What is the question is asked? What is the maximum value of immediate operand if it is unsigned integer? Unsigned means minimum value is all zeros. 6 zeros is the minimum value using the 6 bits. And 6 ones is the maximum value using the 6 ones. So 6 ones is nothing but it is a 2 power 6 minus 1. So that is a 64 minus 1. It is 63. Are very simple. These 6 bits to get a maximum value, there is no sign bit. All the 6 bits are magnitude. That means all are ones. So 6 ones you convert into decimal. So the value becomes 63. If it is a signed, for example, 1 bit you have to stop for sign, and that will be a positive value for the maximum. Okay. So option B is the right option for it. Now coming to the next question. Okay. Now this is the 7th question. Sorry, not 6th. This is the 7th question. I hope you are following. Is it clear? Yes. Now coming to 7th question. Consider a processor with 64 registers and an instruction set of size 12. In the instruction set, we are having 12 instructions. There are 12 instructions. Each instruction has 5 distinct fields. Each instruction has 5 distinct fields, namely opcode followed by 2 source register identifiers, 1 destination register identifier, and a 12-bit immediate value. So total, the size of instruction we do not know. So we are having 5 distinct fields. What are those? Initially there is opcode value. Opcode followed by 2 source register identifier. So source register 1, again source register identifier 2, again destination register destination register identifier, and a 12-bit immediate value. 12-bit immediate value. So immediate value is basically is mentioned it is a 12 bits. So we can take 12 bits. And what is the destination register? We are having 64 registers, whether it is a source register or destination register, we have to use the 6 bits. We have to use the 6 bits. So destination register we take 6 bits. Every source register also we take 6 bits. And we are having 12 instructions. To identify one instruction we require 4 bits, because if I take 3 bits, only 8 instructions I can show. Definitely 4 bits must be taken. Now we got to know instruction size, that is 12 plus 18, 30 plus 4, 34. So 34 is the instruction size. Each instruction will occupy 34 bits of memory. But he mentioned that each instruction must be stored in memory in a byte aligned fashion. Byte aligned fashion means byte by byte you have to store. Byte aligned fashion means byte by byte you have to store. And if the program has 100 instructions, the memory in bytes consumed by the program text is, okay. So 34 bits is nothing but how many bytes? It is a 4 bytes plus 2 bits. But for 2 bits also 1 byte of memory it will occupy. Okay. So each instruction occupies 5 bytes. Instruction 1. So how many bytes it will occupy? First 1, 2, 3, 4. So if you take 4 bytes, it will be having 32 bits only. In the 5th byte also I have to store 2 bits, and remaining will be wastage of space. That can't be used for the new instruction. New instruction I2 should be started from a fresh location. So that means even if 4 bits are wasted, some 6 bits are wasted, so we have to use that 5 consecutive bytes of memory for each instruction. So there are 5 bytes of physical memory space is allotted, even though the instruction size is not exactly 5 bytes, it's a 4 bytes plus some value, some 2 bits extra. Okay, so it will become 5 bytes into the program text is containing 100 instructions. So total we require 500 bytes of memory space for storing the program. So option B is the right option. Yes, 5 into 100 is a 500. Rishabh Pandey, it is not 450, because it is a byte aligned fashion. It is stored means every new instructions have to be started in a fresh byte. Okay. Now coming to the 8th question. Try this. Okay. So now consider two processors P1 and P2 executing the same instruction set. Assume that under identical conditions, for the same input, a program running on P2 takes 25% less time but incurs 20% more CPI, clock cycles per instruction, as compared to the program running on P1. If the clock frequency of P1 is 1 GHz, then the clock frequency of P2 is. If the clock frequency of P1 is 1 GHz, clock frequency of P2 in gigahertz you have to find out. So that is the question actually. So processor P1, it is taking 1 GHz of frequency. So what is the one cycle time here? For 1 GHz, cycle time is inversely proportional to the frequency. So 1 by 1 GHz, 1 by 10 power 9 seconds. 1 GHz is nothing but 10 power 9 hertz. Okay, P1's this thing. Okay, now this is equal to 1 nanosecond. The time for one cycle in a processor P1 is 1 nanosecond only. Okay, so as far as the processor P2 is concerned, okay, when compared to processor P1, as far as the time is concerned, it is taking 25% less time. As far as the time is concerned, it is taking 25% less time. And as far as the cycles are concerned, it is a 20% more cycles it is taking. 20% more cycles per instruction. Okay, as compared to the processor P1. Now, what is the frequency of P2 he is asking. Okay, so now for example, let us suppose that let P1 takes 5 cycles. Let P1 takes 5 cycles. So as far as the cycles are concerned, it is taking 20% more now. According to this comparison, then P2 takes 6 cycles, because 5 plus 20% of 5. 20% of 5 is 1. So it will take 6 cycles because 20% more. As far as the time is concerned, as the time for one cycle is 1 nanosecond in P1, then P1 takes 5 nanoseconds. P1 takes 5 nanoseconds, then P2 takes 25% less. P2 takes 5 minus 25% of 5. So this is nothing but 1.25. It is subtracted, means it is a 3.75. 3.75 nanoseconds processor P1 takes. That's the time. So that means cycles is 6 cycles, time is 3.75. That means in a processor P2, 6 cycles time is equal to 3.75. So usually what is the one cycle time? 1 by frequency, no? 1 by frequency is x gigahertz, for example. So 1 by x gigahertz, 6 into 1 by x gigahertz is equal to 3.75. So x value is equal to 6 by 3.75. So this is equivalent to 1.6. Option C is the right option. Exactly. 1.6. Yes, Shweta Pandey, you are right. 1.6. Option C is the right option. Now coming to ninth question and the last question of this today's session. The CPU has a 24-bit instructions. That means size of the instruction is 24 bits. A program stored at address 300 in decimal. Then which of the following is a legal program counter? Program counter is, stores address of next instruction, right? So when the instruction is of 24 bits, how many locations of memory it will occupy? By default, you can consider the byte addressable memory. Okay. So 24 bits is nothing but 3 bytes. And where it is the program is started initially 300. So 300, 301 and 302. So these are 3 bytes of memory will be allocated for the first instruction. Okay. Now at 303, second instruction will start. Next 345 and at 306, third instruction. Like that, instructions will go in a multiple of 3, because initial address 300 is a multiple of 3. Then if it is a multiple of 3, then only it is a valid, legal. 400 is not a multiple of 3. 500 is not a multiple of 3. 7 also not a multiple of 3. 700. So option C is the right option. That is a multiple of 3. I hope you have understood this. So the option C would be the right option for this. I hope you have enjoyed the session. And still, if you have any doubts, you can just comment in the comment box. I will definitely attempt it. You could also see the responses at what I have given for the previous session of YouTube for the digital logic part 1, part 2 and part 3. Okay. Once again, I am giving you this information regarding this NIELIT exam. NIELIT exam is having some change in the date. In the November 22nd is the date of the exam. Okay. So please observe this change, note this change. Okay. That's all about this. And before concluding the session, so let us congratulate our Gradeup toppers in the engineering services exam and also the GATE exam. In the year 2020, we got all India 4th rank, 6th rank, 999, 20, 25, all those things you can see. Okay. So in a CS, we got 4th rank. Okay. You can just have a look at here. 4th rank we got in CS, and also we got 20th rank, we got 39th rank, and also 47th rank. Even for 2018 also, for engineering service exam, ECE candidate has got the top rank, and 2019 we got toppers. So I wish every one of you also be in this top list in future. So we got around 60 plus Gradeup students are in top 100. So there is a very good achievement for the 2020 year. Okay. So now coming to the Gradeup Super. Gradeup Super, if you are opting for this, so you can have an unlimited access to the structural live process and also the mock test. Okay. In a structural live courses, you can have the access to the India's best faculty lectures, and with complete doubt resolution, with full coverage of syllabus according to your exam pattern, and also you will get online mock test, and which are designed by the toppers based on the latest pattern of exam. So that is a green card. Okay, and you can subscribe to the Gradeup Super just by downloading the Gradeup app from the Play Store, and you can reach us at 96500 if you have any doubts related to these courses what I taught, like Gear Up course, Rank Up course, and also the Vision 2022 course. Okay, and as far as the subscription to the Gradeup Super is concerned, so there are different details I have given. Please go through this. For getting an access to the preferred live courses with the Gradeup Super, what you have to do, all that is Gradeup Super, you have to subscribe. Subscription is required. Go to the Play Store, download the app, and then go to the subscription. Doubts you can reach us here at 96500 You can also mail us at help@gradeup.co for any of the courses. Okay. So any course can be joined by anybody. There is no barrier. But Vision course is ideal for the long-term place, so for the working people and also for the secondary students, third students. And Gear Up is ideal for the people who wanted to revise the entire syllabus, and Rank Up is ideal for the repeaters. Okay. So here we are having a 6-month subscription in the Gradeup Super. Per month you have to pay 2,000 and total of 12,000 rupees. For the 12 months, 1 year subscription, per month you have to pay 1,400 and a total of 16,800 rupees. And for 2 years subscription, 24 months, you have to pay per month 1,000 rupees, total of 24,000. Okay. So for any doubts, you can reach us at 96500 or you can also mail us at help@gradeup.co. Okay. So this is about the Gradeup Super and its subscription phase. And that's all about this today's session. And tomorrow also we are having a session on the instruction pipelining. That is a much more important session. I expected participation of every one of you again, and also you can inform to your friends, those who are not attended for today, so they also will get an advantage of this. So thank you very much. Thank you one and all. Go Gradeup, prepare smart, score better, and stay safe. Thank you. Have a good night.